All right, so in this section, we're going to be talking about the mass percent composition of a compound. And when we talk about percentage, first of all, we need to sort of understand what that means, right? A percent in any sense means the part over the whole. So percent of, let's just say something, is equal to part over the entire thing, the whole thing, times 100, right? So we're looking at essentially that fraction, whatever fraction of that substance that that is made up of that thing that we are concerned with, divided by the entire substance, the whole, times 100. We're going to be using this relationship, this percent relationship now, and apply it to our chemical compounds, specifically by looking at the formulas. So when we talk about the mass percent composition, what we're looking at is the amount or the mass of that element in that compound divided by the total mass of the compound times 100 to give us our percentage. All right, so when we talk about the mass percent of an element in a compound, it's the same idea. It's the mass of that particular element, which is going to be our part, divided by the entire thing, the whole thing, which is the mass of the compound, and that's our whole, times 100. Right, and that's the formula that we'll be using specifically for mass percent of an element. We can use what we learned in the previous sections, which is the molar mass, to compute what the mass percent of an element in a compound actually is. So let's take a look at an example, and we'll kind of walk through this process. So it says the odor or the smell of pears is due to the organic compound, which has a funny sounding name. But the key thing here is the formula. All right, so we have the formula for that compound, and we need to determine the mass percent composition of, let's just clarify this, of each element in that compound. Okay, so what we're given here is the formula. So that's our chemical formula for this compound, and it's C5H10O2. So the way that we can determine the percent by mass of the carbon in it, or the percent by mass of the hydrogen in it, or the percent by mass of the oxygen in it, is just by using the most obvious thing that we can use in this chemical formula, which is the mass of 1 mole of it, or the molar mass. All right, so we're first going to do, or what we are first going to do, is determine the molar mass of this compound. All right, and the molar mass is simply adding together each of the individual molar masses for the elements multiplied by how many of each of the elements we have. So we have 5 carbons plus 10 hydrogens plus 2 oxygens. All right, and we can look up the individual molar masses for each of these, for the carbon, for the hydrogen, and for the oxygen. We can look those up on our periodic table. All right, so we're going to have 5 times carbon is 12.01 grams, plus 10 times hydrogen is 1.01 grams, plus 2 oxygens, and oxygen is 16.00 grams. All right, so we just add those up and we get our molar mass for this particular compound. So let's just see, 12 times 5 is 60.05 plus 10.10 plus 32 60.00 grams, and that's going to give us a total of, let's see what we have here. That's 60, that's 70. So that's 102.15 grams. All right, so that's the molar mass for C5H10O2. So once we have our molar mass, to determine the mass percent of each of those elements we have in the compound, we actually already have determined those numbers just by calculating the molar mass in the first place. So let's take a look. The percent by mass of carbon would be the mass of carbon divided by the molar mass times 100, right? And we already have the mass of carbon up here. So we have 60.05 divided by 102.15, our molar mass, times 100. All right, so we have here the mass of carbon is going to be our part, the molar mass is the whole, the entire thing. All right, and then this is going to give me 58.79% carbon in this compound. And then I'm going to do that for each of the other two elements that I have. All right, so the second one was the hydrogen, and we calculated the hydrogen. The mass of the hydrogen in this compound, and 1 mole of it is 10.10 grams. So then the percent by mass of hydrogen is the mass of the hydrogen divided by the mass, by the molar mass, times 100. We already calculated the mass of the hydrogen in the compound. It's 10.10. Divided by the molar mass, 102.15 grams times 100. And that's going to give us 9.89% by mass of hydrogen. And then the third would be the mass of the oxygen, and we have 32 grams of oxygen in that compound. So the percent by mass of O would be the mass of the oxygen divided by the molar mass times 100. So we saw that was 32 grams of oxygen divided by our molar mass, 102.15 grams times 100. And that's going to give us 31.33% oxygen in our compound. All right, so what we're using here to make our calculation a little bit simpler would be to just use the chemical formula that's given. We can calculate the molar mass simply by adding up all of the individual molar masses for the elements, and then we've already, by doing that, then we would get the mass of each of those components. We just simply divide the mass of each of those components by the total mass, which is our molar mass, times 100, to give us our percent composition by mass.